welcome to the GSA metric construction video. Our purpose today is several-fold. We'll cover general information about the law and the executive order that started metric conversion in the United States recently. We'll cover a few of the benefits of the new system in day-to-day construction activity. We'll cover projects being done throughout the United States by many federal, state, and municipal public works agencies at this point. We'll also cover some administrative questions, such as does it cost the same to design in metric, and what are the construction bids reflecting for metric construction projects. We'll also, on a discipline-by-discipline basis, cover technical questions frequently asked by many architects and engineers, such as what are we calling the 2x4 in U.S. metric construction. We'll also have some recommendations for individuals both selecting pilot projects and responsible for converting an organization to the metric system. The information today comes from a number of different sources. We've been working closely with Public Works Canada and learned many of the lessons that they learned through metric conversion. We've done consultation and training for several thousand architects and engineers throughout many of the major federal and state builders. We've done product research with over 600 companies, so we're well aware of the products that are made in metric in the United States. We collected many foreign drawings and codes prior to converting our organization to metric, but first and foremost the information comes from pilot projects that we now have both in design and in construction, and the day-to-day lessons that we've learned from those activities. GSA has 10 regions throughout the United States, and the Region 3 in Philadephia is a medium-sized region. We do several $100 million in construction a year. We've been doing pilot projects in metric for several years and have been designing almost all of our capital projects in metric, so that from this time forward almost all of our construction on capital projects will be in the metric system. So without any further ado, let's start our presentation. Several years ago, the United States Congress passed a law which modified previous legislation and significantly strengthened metric conversion efforts in the United States. This was followed up in 1991 by a presidential executive order that required all federal procurements to be in metric by September of 1992. It then created an organization that established 11 sector committees to look at all the areas of federal procurement. There are sector committees for healthcare, transportation, fuel and power, construction, education, among others. The material today deals with information strictly related to the Construction Sector Committee. Each sector committee was asked to look at that September 1992 date and establish if it was feasible for their particular sector to do their procurements in metric. Due to the complexity of construction, the Construction Sector Committee recommended that January 1994 be adopted as the date after which all designs in the federal community would be developed in metric. There are two main goals for metric conversion: exports and efficiency. The example we like to give for exports is the 2x4 ceiling tile used throughout the United States. Many of the companies that manufacture 2x4 ceiling tiles also have manufactured metric sizes for export. The goal then is to go to one product size that works both in the United States and abroad. On the efficiency side, individuals who use numbers, hundreds and thousands of them, on a daily or weekly or monthly basis can save a good deal of time by going to the simpler and more efficient decimal system. However, our understanding is that the executive order does not touch many areas of our lives. The areas that are technical and will bring long-term economic benefit to the United States are the thrust of the metric conversion effort. But the non-technical areas of our lives, such as converting NFL football to metric, changing the baseball diamond, recipes in the kitchen, and TV weather broadcasts, are not directly impacted by many areas of this executive order and the metric conversion effort. Again, exports and efficiency, let's follow with a few examples of how we can save a good deal of time by going to the simpler metric system. In the United States, we have several units that say the exact same thing. In heating and air conditioning, a chiller, a major portion of the air conditioning system, would be classified as a 1,000-ton unit. And the boiler, similar to the device in your home, would be classified as 22 million BTUs per hour in thermal capacity. If we were to ask, theoretically, to turn both of these pieces of equipment on full speed, would the building become warmer or cooler? And it's difficult to know that in our current system. Those exact same pieces of equipment, looked at through the metric system, reveal that about 3.5 megawatts of air conditioning capacity would be available versus 6.4 megawatts in heating capacity. And we see right away that there would be a great deal more heat going into that building as air conditioning capacity available. There are also many examples in the architectural field where using the metric system makes day-to-day operations simpler. 8-inch CMU block, also called concrete block or cinder block, is a very common building product, but how high would 16 rows be? So we multiply 8 times 16 gives us total inches, then we divide by 12 gives us feet in inches, and if other products with fractions of inches are added to this total height, this becomes a 3 to 4 step process to find the total. The metric block that we have already used on several U.S. projects is very similar to 8-inch block, but using the metric system makes addition much simpler. We multiply by 2. 2 times 16 rows equals 32, or 3,200 millimeters. Likewise, 8 rows times 2 equals 16, or 1,600 millimeters. Another simplified example is that the average person puts out about 250 BTUs per hour of heat that we can actually feel. Is this more heat than a 100-watt light bulb? That same person is putting out about 70 watts of heat, making for a much easier comparison. If you followed some of the trade issues, the difficulty is not that the other economies are larger than ours, but many countries export more products to the United States as we export to those countries. Many countries have also identified the lack of metric products as a factor in their lack of desire for buying U.S. products. So making products in metric will make them obviously more attractive overseas. And then the daily operations of the U.S. government and other agencies can be improved by going to a simpler and faster decimal-based system. Many agencies throughout the U.S. have selected pilot projects in anticipation of the January 1994 date. In Kansas City, Missouri, GSA has a 20-story courthouse being designed completely in metric, valued at about $90 million, as well as a new federal courthouse in St. Louis, Missouri, valued at over $200 million. In Philadelphia, my full-time project is a new computer center for the VA. The project was completely designed in metric and is now out for construction bids, with construction to begin in early 1994. The building is about 2 football fields long on the front face, so for us it's considered a major structure. The total project cost is valued at about $70 million. GSA also has a storage facility addition in Washington, D.C. C represents construction, as well as a new GSA building outside of Denver, Colorado. GSA designs and builds many facilities at Canadian and Mexican border crossings. We now have a facility under construction in southern Arizona being managed by our San Francisco office, which involves a new border station facility and reconstruction of a portion of Arizona State Route 286. We also have a new facility in design in northern Vermont and a new facility already in construction in northern New York State, those projects both being managed by our New York City office. In addition, we have a border station facility in design valued at about $15 million at the southern Texas border crossing into Mexico, managed by our Fort Worth office. Another project is a new federal courthouse that we have in design in Tampa, Florida, being managed by our Atlanta, Georgia office, valued at about $70 million. Our existing federal building in Richmond, Virginia, is one of the first to undergo a complete renovation in the metric system. The project is now well into construction, and is estimated at about $18 million. The complete replacement of the air conditioning system for one of the largest federal complexes in the United States is now complete, having been constructed completely in the metric system. Another project involving renovation of 2 floors of an existing federal building in Baltimore is also now in construction. The new FBI building being designed by SOM for Washington, D.C. is now in design with an estimated total of $70 million. In addition to these many volunteer projects selected throughout the country by various GSA regions, GSA has adopted the national policy of January 1994. After that date, all designs will be in metric. Almost all other major federal agencies that do construction have adopted January 1994 as the policy date, after which all of their major designs will be in metric. Smithsonian, for example, has several major projects now in design and in planning in metric. A new American Indian Museum right on the mall in downtown Washington is valued at about $90 million and being developed completely in metric. Also, a new research center in Suitland, Maryland, about a $40 million project, and planning has started for a new $160 million master plan for the entire Smithsonian complex to be designed and built completely in the metric system. In the area of healthcare, movement by the federal community has been decisive. The Public Health Service will soon be constructing a new health center in Spokane, Washington, and has many other hospitals in development around the country in metric. The National Institutes of Health is now designing an addition to their primate center and also has about $60 million in mechanical and electrical upgrades to their existing research facilities also in development. The Department of the Interior is also moving to the metric system. Plans are now being developed to renovate one of our most prized national historic assets in metric, Independence Hall in downtown Philadelphia. The National Park Service also has projects at the Delaware Water Gap, New River Gorge in West Virginia, and the Ozark Mountain Scenic Riverway in Arkansas. Other groups within the Department of the Interior are the Bureau of Indian Affairs, which has several road construction projects in design, and the Bureau of Land Management, which also has several projects in the development phase. NASA has pilot projects at every space center around the country, from the Jet Propulsion Laboratory in Pasadena, California, a new laboratory at Johnson Space Center in Houston, a new payload fabrication facility in Maryland, a laboratory in Cleveland, a new calibration facility in Huntsville, Alabama, and another new facility at Kennedy Space Center in Florida. 31 new projects have also recently been switched to the metric system. The United States Coast Guard has also switched some of their larger projects to the metric system. A common project for the U.S. Coast Guard is the construction of multi-mission stations which support a variety of activities. The Coast Guard has new stations in design in Maine and Cleveland, as well as a new health center in Alabama. The field of aviation, both military and general aviation, will experience a significant movement toward the metric system based on recent activities. The Air Force was one of the first federal agencies to have metric construction projects. Projects are being done at many air bases around the country. The projects range from replacement of hangar lights, new facilities, taxiway replacements, refueler area modifications, and new base gatehouses. Over the past year, the U.S. Army Corps of Engineers is widely viewed as having become one of the strongest programs in terms of metric conversion. An information paper in June of 1993 established many of the details. It identified that new standard designs within the Army Corps would be developed around hard metric modules for items such as operations and simulator facilities, barracks, hazardous material processing facilities, as well as hangars. It also identified some information about the specifications used in the Army Corps. The Army Corps does have two sets of guide specifications, one for military construction and one for civil works projects. In a rather short period of time, all specifications for the military construction program have been converted to metric, and those for the civil works side will be shortly completed. It also identified that January 1994 is a target date for all designs within the Army Corps to be in metric, except where not economically feasible, and also established a headquarters level committee to oversee the conversion process. The renovation of the Pentagon is one of the largest U.S. Army Corps projects in the world, valued at nearly $1 billion. The project was switched to the metric system and is now well into the design process. The Office of the Secretary of Defense also does many small renovation projects in the facility and has decided to develop all new designs for small renovations in metric until the larger renovation project takes precedence. There are now 3 construction projects already in the construction phase within the structure itself. The Army Corps also has several $100 million in pilot projects at various districts and divisions around the country. There is also a new $12 million harbor developed by the Civil Works Unit of the Alaska District, which will soon enter construction phase. The Department of Energy is another major federal builder. In many of the national laboratories and installations around the country, billions of dollars of projects are now in various stages of design and construction in anticipation of January 1994. Until recent developments, the Super Collider project in Texas was proceeding with design of nearly $7 billion in technical components similar to those shown here. The Advanced Neutron Source is a $2.5 billion advanced research complex for the Department of Energy. The project is now in design phase, completely in metric, in Tennessee. The Department of Energy also has many other activities being developed in metric at this time. There are many new laboratories and smaller renovation projects already in development. The Bonneville Power Administration has several control substations as well as a control center already in development metric, and other activities like the Human Genome Laboratory are in planning completely in metric, as well as other activities around the country. For many years now, American cars and trucks have been built in metric throughout the United States. Soon too, the American road will also be designed and built in this exact same system. The Federal Highway Administration has directed that all construction after September of 1996 must be in metric in order to receive federal financial aid. Since it can take 2 to 3 years to develop a major state transportation project, many of the largest state projects are already being surveyed or developed in the metric system. Many states have already started all of their survey work in metric, and many states have also started the process of converting their standard drawings and specifications to metric. An August 1993 survey indicated that over half of the states have already started that process. Many states also indicated they already have designs underway in metric or would select them in the near future. These states indicated that they already have either highway or bridge projects now in design in metric. Those with an asterisk indicated they would have metric pilot projects in design by late summer of 1994. Many municipal public works and engineering departments also utilize the standard drawings and specifications developed at the state level or receive federal aid for their own projects. So they will be directly impacted by the federal transition effort. We speak with many technical representatives from these organizations and know that many have already selected pilot projects to be designed or are already designing in metric to get ready for the eventual transition. Also, many port authorities, utilities, aviation authorities, and public transit organizations have contacted us for technical information and also indicated that they're undertaking activities to prepare for the transition to metric also. Within the Department of Justice, the Federal Bureau of Prisons has directed that all detention facilities designed and built after January of 1994 will be designed in the metric system, and the selection of the first specific projects is now beginning. Projects are also being done at many other federal organizations around the country. The Department of Agriculture has directed facilities projects to be in metric starting in January of '94 and already has a number of construction projects underway. Within the Naval Facilities Engineering Command, much of the criteria has been converted or is now being converted to metric. Many of the specifications used within the Naval Facilities Command are now converted to metric, and many of the details of converting the construction program are being discussed within the Navy management levels. Other groups within the Navy are also doing projects in metric. Many of the weapons acquisitions, such as one of the first major naval weapons acquisitions, such as the LX amphibious assault ship, is now being designed and procured in metric. Other groups within the weapons area for both the Navy and the Marine Corps have started procurement of items such as aircraft, jet engines, tanks, amphibious assault vehicles, and watercraft of different varieties. It is also foreseeable that the facilities related to the construction, procurement, and calibration of these weapon systems may be impacted by the metric conversion of the actual weapons themselves. A number of projects are indicated at several Navy Public Works offices as well. There are also projects being done within the VA medical area. They're one of their first major capital projects to be done in metric. A new $170 million hospital is now being developed in metric in Florida, and projects are also being done within the EPA. It is now fair to say that metric conversion throughout the federal construction community has largely occurred. Many of the policies, but more importantly, major projects have now begun to be designed and constructed in the metric system. The lion's share of all projects that start design in 1994 and beyond will be done in this new metric system. Estimating the total number of dollars now being developed in metric around the country is not an easy task, but based on the projects that we know about, as well as estimates of agency construction budgets and federal money spent on state projects, we feel it's reasonable to say that about $20 billion is now being planned, surveyed, designed, or already constructed in the metric system around the country at this point, with several $100 million in new projects being added on a weekly basis. A number of individuals are skeptical that this effort will not be successful, that it will be similar to the metric conversion undertaken earlier, a number of years earlier, but we point to the huge volume of projects that are now being started throughout the federal and state communities as well as local levels now as the best evidence that this will be permanent. Projects are being designed now in every state of our country, and for virtually every American there's a project being either planned or designed in metric within 1 to 2 hours of your home. Based on our design and construction experience in metric, we've been working in metric for several years now. Almost all of our construction for capital projects will be metric, as well as based on discussions that we have on a continuous basis with project managers at state and local government agencies. We feel that any road, building, bridge, or public works type project can be designed and built successfully in metric at little to no cost impact and little additional effort, provided the reasonable approach established later in this video is utilized. The next two sections cover administrative and technical issues. The administrative section does deal with the most frequently asked questions that we've heard involving our training courses with project managers, architects, engineers throughout the United States in both government and private sector organizations, as well as the most common lessons learned that we've uncovered through our design and construction experience. For this administrative section, you will need the one-page document entitled the M3 Video Supplement, which has many of the key points that we'll be discussing over the next few sections written down for easier reference. You'll see that Section 2 of your supplement lists the 15 topics that we'll cover in the administrative section. The first item is design firm abilities. We find the same firms that did quality design for us in the English system are now applying for our projects and also producing quality designs in the metric system. Firms with and without metric experience have developed metric designs that have been successful for us at this point. We also find that both large, medium, and small firms are producing metric designs at the same caliber, depending on the level of preparation and effort put forth in the design phase. Of the 500 largest design firms in the United States, nearly half of them reported doing overseas work last year. Much of this work is in the metric system. In terms of the design cost, we're finding that we're generally paying the same for design under the metric system as we did for designs that were developed under the English system. Initially, there was some cost premium, and that was attributable to 4 items. Initially, our specifications were not in metric. Our criteria, such as handbooks and manuals, were not available in metric version. We were not sure if the estimating programs and documents that we use would be available in metric version. We were also not sure if codes and standards that we commonly reference in our construction projects were available with metric units in them. And due to the uncertainty, we did allow some small premiums on a few initial projects. At this point, however, these 4 issues are largely addressed. Our specifications are completely in metric. Our criteria, design handbooks, and so forth are now available in metric version. We found that the estimating programs utilized throughout the commercial industry are available from virtually every major firm in metric version, and over 90% of the codes and standards that we utilize have metric data in them after an extensive review of all the material that we utilize on a regular basis. Many projects throughout the federal community have been switched to the metric system in the design phase at no cost. It is now GSA national policy that there will be no allowable premium to design a project in the metric system. Our third topic is construction firm abilities. Many have asked what contractors will think when they see plans and specifications developed completely in the metric system. To answer that question, we contacted about 100 of the 400 largest general contractors in the United States to gauge their response, asking them if they've ever worked in metric with their current staff, if they feel they could work at little to no effort on a metric project in the United States. And we also track which firms have bid metric projects and solicitations, with the conclusion that if they bid a project in metric, they are able to work successfully in the metric system. We are seeing the same firms bid our projects in metric as previously bid our English projects. We have not seen only the largest firms bid our projects, but both small, medium, and large firms alike. We now track which firms have bid metric projects and which firms are currently doing construction in the metric system on a state-by-state basis. We can assure you that the same firms that bid your previous projects will now bid your metric projects, provided that a good, strong communications effort is made to communicate the details of metric construction that you're using over 90% of the exact same products that were used on previous projects. As far as construction costs, we have seen no increase in our costs. The prices for our bids have been about the same as our previous English projects, with no statistical deviation either way. That only includes projects that have been bid so far in metric up to about $20 million in construction costs, but we feel quite confident that the details of metric construction have been worked out, and that a project of $40 million is using the exact same process as a $20 million project, and that the cost will be equivalent to our previous English projects. In general, we feel the larger that a project is, the less chance there will be any premium for a variety of reasons that we'll go into later on in the video. We do not, however, recommend very small projects, and the details of why will be clarified in a future item in the administrative section. The next topic is switchover. For those that have an existing project being done in English, at what point is it feasible to convert that to the metric system? And in general, we would say about 30 to 40% design completion is about the threshold to convert a project to the metric system. My project was developed through conceptual design up to about 30% in the English system and switched to the metric system at that point successfully. Topic 6 covers dual dimensioning, which means that both the metric measure and the English measure are placed together. We view dual dimensioning as a complete waste of time in a set of drawings and specifications for a construction project. When the English measurement is present, the individuals responsible to build the project will simply use the English dimensions. Our projects now require only metric in both plans and specifications. The analogy we like to give is when one purchases a major appliance, the instructions are given in 7 languages, and we immediately go to the language that we're most familiar with, be that English or another language. Our next topic covers what we like to call public and technical data. We recommend that 95% of the information on a typical project be done strictly in metric units only. Drawings, specifications, daily project correspondence, reports, technical data, area of the project, as well as cost data such as dollars per square meter, dollars per kilometer of highway. We recommend this type of data on a day-by-day basis be generated strictly in metric units. There is, however, about 5% of the information of a typical major project that interfaces with the outside world with those not directly involved in the day-to-day details. An example we like to give is if a senior manager called and asked what size his room would be in the new building, we would probably say about 16 by 20 feet. And this bilingual approach can really smooth a transition to the metric system for a typical organization. And another example we like to give is a foreign car built completely in the metric system overseas. When they come to the United States, the literature that interfaces with the public and the consumer commonly says this car has about 12 cubic feet of trunk space, when in reality the product was designed and built completely in metric. So we do not discourage the selective use of English units for that few percent of interfaces with the outside world. Our next topic deals with soft and hard metric. If you look at section 3 of your supplement, we provide a convenient definition for those two terms. Soft metric simply means there will be no change to the product, no physical change at all. A nice example is the telephone that's on your desk at work can be described as 8.5 inches wide or just as easily described as 215 millimeters wide, but it is the exact same product. Hard metric, however, means that we're going to a new metric product and it is not compatible with the old product. A good example is the 2x4 ceiling tile. Is a very common product. On our new metric jobs, we are using a 600 by 1200 millimeter ceiling tile. It is not compatible with the 2x4. It cannot be interchanged. It is a completely new product, in a sense a hard metric product. The next section covers units and rough conversions, and a few basic units are needed here. 1 meter is equal to 1,000 millimeters. 0.2 meters could be written as 200, and 4.5 meters could be written as 4,500. There has been some debate on the use of centimeters, but our projects require almost all dimensions to be in meters and in millimeters. While there are many detailed conversion factors that can be memorized, we find it far more beneficial to remember some rough rules of conversion, such as the following. 1 inch is about equal to 25 millimeters, 4 inches is about equal to 100, and 1 foot is about equal to 300 millimeters. So when we begin to use numbers like a 6-inch concrete pad, that would be roughly converted to 150 millimeters. We find these much more beneficial for learning a feel of the metric system. Many folks say they will not be able to develop a feel for meters and other units, so we've developed a few rough rules of thumb to help in that area. Section 5 of your supplement has these rough rules of thumb for easy reference. The first one is the rule of threes for converting feet to meters. If we estimate that 40 feet is the English dimension, multiplied by 3 gives you 120, and move your decimal 1 place to the left yields 12 meters. Likewise, 60 feet times 3 would be 180, yielding 18 meters. And these are fairly accurate conversions. Likewise, for area, divide by 10 to get a rough feel for square meters. 40,000 square feet divided by 10, about 4,000 square meters. For acres, the rule of 4s applies. 10 acres times 4 is 40. Again, move your decimal, yielding 4 hectares. For miles to kilometers, we find the 1.5 factor is an easier item to use than the exact 1.6. 200 miles times 1.5 yields 300 kilometers, which is not too far from the actual 320-some kilometers using the actual conversion factor, but much easier to understand and have a... So what will be the difference between a metric and an English project? Topics 10 and 11 in the administrative section give us some important information here. These are also shown on Section 6 and Section 7 of your supplement. The first important principle is the 90% rule, and that is that 90% of the same products that we use now we'll also use on a metric project. However, instead of giving the dimensions of the product in inches, we'll now give it in millimeters, and also instead of pounds, we'll describe it as kilograms. But they are 90% of the exact same products that we're currently using. On the other hand, another term is called design dimensions, and those are installation heights, mounting heights, lengths, and widths that we install in the field but have little to do with the actual products themselves. Examples are as follows. These are examples of design dimensions. On these dimensions, we want to strive for 100% pure hard metric numbers that are rounded, even, meters and millimeters. The width and length of a room. The mounting height of a wall switch to turn the lights on could be 4 feet or raised an inch or two to an even metric number. Runway width and length. Bridge pier center to center could be 45 feet or modified to 15 meters. The ceiling height of the room that you're in could also probably be raised an inch or two without changing the net result. And also an example is the width of a highway lane can be modified by the field installation process and changing the dimensions of the forms. So again, the important point is to remember that 90% of the same products that we use in an English project we'll also use on a metric project, like a fan, an electrical transformer, airport runway signs, as well as pumps and valves used in a water treatment plant. Same exact product, now dimensioned in millimeters. There will be no disruption or change in the installation of those products. However, for design dimensions, we want to strive for even, rounded metric numbers so that the people installing these products in the field will have an easier time working in even 1, 2, and 5 meter increments. Our next topic covers codes and standards. We've found that over 90% of the codes and standards that we utilize for our construction program, many of the same codes and standards used in state, municipal, and private construction already have incorporated metric units and dimensions. Of the 3 regional codes used in the United States, both the BOCA and the SBC already have incorporated metric, and UBC is planning to incorporate metric units in the next update of their code. The National Electric Code also has metric dimensions. the NFPA fire safety standards, the life safety code, the UL standards, many of the ASTM standards that we use, the ANSI elevator codes, and also a majority of the AASHTO transportation specification standards that we utilize in our projects already have incorporated metric. Our next principle deals with metric-only criteria. We recommend that all new criteria be developed in metric only for several reasons. The first is that issuing a directive to go metric and then issuing criteria in both English and metric can appear slightly contradictory. The second and more important reason, though, is that the construction professionals with years of experience will not forget the old units and measures that they're used to. The example we like to give is that 12 feet was a typical minimum roadway width, and in the new metric system that dimension is now 3.6 meters. In our experience, when we issue criteria that says 3.6 meters only, the tradespeople and the construction designers do not forget that 12 feet dimension for years and even decades to come. So we're recommending that handbooks, technical manuals, reports, and standards be issued in metric only, and this facilitates a pure metric thinking process quicker than issuing dual dimension criteria. The other principle is regarding the selection of pilot projects. Any project of size and duration we feel can now be designed and successfully constructed in the metric system. The key, however, is to recognize that you're asking professionals and tradespeople to learn a new language. The example we like to give is if you were asked to do a 2-week rotation in Russia, you would probably not find it worth it to study and learn the Russian language. But if you were asked to go there for 2 years on a technology transfer assignment, it would then become worthwhile to spend a few months to learn the Russian language and the basics of how the language works. So again, a project of 6 to 8 month duration or longer, a multi-year project, is ideal, and the tradespeople and designers will find it worth it to learn the new metric system and buy the tools that are needed. We generally recommend that the larger the project, the less impact you will have through metric conversion at all. Larger projects have larger buying quantities, and you can usually get the metric products at no cost premium or little cost premium. Any additional lead times can almost always be incorporated. There's an additional 1 to 2 week lead time for a product. It's not an issue on a 2-year or a 1-year project. You have many tradespeople and many architects and engineers on a larger project, and chances are greater that some of them will have had some metric experience and they can help others, we have found in our projects. So a very small project, a $5,000 or $10,000 project, even with good intention, would not be our best recommendation for a metric project. We generally recommend the larger the better, and we project a small or no impact on those types of major capital projects. Our last topic, the communication of metric activity, almost goes without saying, but we wish to emphasize the importance of communicating with internal staff, local contractors, local design teams, architectural and engineering firms, as well as trades and unions that will be involved on metric projects, that the metric projects are now in progress and providing time frames on when they would need to be prepared. It's also very important to provide them written technical reference material so that they understand the changes to the process of construction on your projects. In summary, we feel any bridge, road, marine type project, building, correctional facility can be built in metric at approximately the same cost using the compromise administrative principles established earlier, as well as making sure that a strong partnership exists and good communication between the many organizations involved in a major construction project. Again, a critical issue in our opinion is the size of a project. Larger and medium-sized projects provide us a duration and a motivation to learn the metric system on a permanent basis, and can help you avoid some of the pitfalls and some of the negative resistance that could impact a very small project. At this point, we'll move on to our technical section. This section covers the most frequently asked questions about products used in metric construction. Section 8 of your supplement covers architectural issues. The most commonly used door size on a metric project is a 900 by 2100 millimeter door size, slightly smaller than a 3.0 by 7.0 door. For drywall, we're using the exact same thickness, 1/2 inch and 5/8, but most architects are now calling it 13 and 16 millimeter thickness, but it's identical to the English sizes. The sheet size, however, is different, and the new size is a 1200 by 2400 millimeter size, sometimes called a 12 by 24 sheet, and this allows use of a 400 millimeter stud spacing. The first of our projects that will use the hard metric drywall are now in construction phase. Regarding masonry, a standard metric joint is 10 millimeters. Standard metric modular brick is 57 millimeters high. 57 plus 10 equals 67, and 3 bricks, 67 times 3, equals 201 millimeters, which is rounded to 200, equaling 1 block coursing. The standard block that we have now used on several projects is 190 millimeters high, plus a 10 millimeter joint equals 200 millimeters, equal to 3 metric modular brick. Jumbo brick is 90 by 90 millimeters, thus 90 plus 10 equals 100, and 2 jumbo brick equals 1 metric block coursing. The current standards for glass already include millimeters in the specifications. Our projects now specify the glass thickness in millimeters only, with 6 millimeter being a very common thickness. Lumber is a soft metric conversion. The familiar 2x4 has actual dimensions of 38 by 89 millimeters. Our experience shows that most folks will still call the product a 2x4, but they will use the actual millimeter dimensions in layout of field activities. Plywood is handled very similarly to drywall. Most folks are referring to a 3/4 inch plywood now as 19 millimeter thickness, but there is no actual change to the thickness of the product. We are, however, specifying a hard metric sheet size, the same as the drywall, the 1200 by 2400 millimeter sheet size, allowing a 400 millimeter stud spacing for housing and barracks and similar activities, as well as formwork. Sheet metal, on the other hand, is now specified in hard metric thickness, but we do allow the most closest gauge to be submitted and to meet the specification. For example, our spec would show 1.6 millimeter thickness, but the next highest gauge thickness would be submitted provided it meets the minimum thickness requirement. In the area of civil engineering, 2 common products are concrete and rebar. We have found that concrete will flow to the forms if they are laid out in millimeter dimensions. Concrete is now specified in megapascals, or MPa, with the most common being 25 and 30 MPa, replacing the common 2500, 3000, and 4000 psi concrete we previously used. Rebar is measured in M, 10 to 55 m, meaning nominal 10 millimeter diameter up to about a 55 millimeter diameter. There are 8 new metric sizes which replace 11 sizes under the old system, a significant reduction in inventories. There are now several firms that will supply these rebar, and other firms have committed to supply them when the federal procurements begin to take place. In terms of stationing for civil engineering projects, the state highway departments are roughly divided on whether to use 100-meter stations or kilometer stations. Our projects may use either depending on the state that the project is executed in. In terms of surveying, most surveyors have indicated that the metric system is just another decimal system for them to use. Most electronic data measurement equipment will also handle metric at this point. Section 10 of your supplement shows a few items in the structural engineering area. Our most common floor loading rating is now 5 kilopascals, which is close to 100 pounds per square foot. Other products include these. Structural steel is a soft conversion. A W40 is now called a W1000, but it is the exact same product. Bolts will go hard metric. The A325 bolt will be replaced by the ASTM A325M for metric, a reduction in 2 sizes. Anchor bolts are also going metric and are shown similar to this. The M16 would mean a 16 millimeter nominal diameter anchor bolt. In the area of calculations, we have allowed some calculations to be done in English, but the net result, the drawings that are to be used for construction, must be in metric only. Some project managers have required all calculations to be in metric also. We now have several buildings using Celsius for temperature control. So we know the difficulties associated with it and realize that this is not as difficult as first imagined. In the area of grills, we are now using grills that will fit into the metric 600 by 600 nominal grid system, commonly called the 6 by 6 grid, slightly smaller than the 2 foot by 2 foot grid previously used. We now require all ductwork to be in 50 and 100 millimeter sizes unless not possible, such as the two sizes shown here. In the area of pipe, this is a soft conversion. A 2-inch nominal pipe is now called a 50 millimeter nominal pipe, but it is the exact same product. All your fittings and connections, whether they are flanged or threaded or other connections, are identical. There is no need for adapters in the area of mechanical pipe. In the area of calculations, again, we have allowed some calculations to be done in English, but the net result is that all flow rates shown on drawings and in schedules must be in metric only and must be rounded, such as 75 liters per second. We should say that software to do both mechanical and structural calculations is now widely available for U.S. construction in metric. In the electrical area, conduit is also a soft conversion. A 1-inch conduit is the exact same product, but it now has a new millimeter name. All your fittings and connections are identical. Much of your electrical equipment already uses Celsius for its thermal ratings, so there is little difficulty in converting to metric here. In the area of conductors, most projects are still using American wire gauge, but many U.S. companies produce square millimeter sizes, the sizes used in many countries throughout the world. These are available and could be looked into for possible application on U.S. projects. Fiber optic products are now commonly specified in U.S. industry in micrometers, such as 125 micrometer cable. Federal telecommunications standards are also now being developed in metric based on maximum runs in meters and kilometers. In the area of lay-in fixtures, we have had little difficulty obtaining 600 by 600 and 600 by 1200 fixtures. Many firms can make these or have already made them for export to other countries. On our bids, we have seen the prices are generally comparable to 2x2 and 2x4 fixtures. These fixtures utilize the exact same lamps as a standard 2x4 fixture. In the area of road design, many products have been converted to metric with little difficulty. The AASHTO M180 guide rail standard already includes metric data in the standard. Other products are also soft converted, no change to the products such as galvanized H-posts and also timber posts, button head bolts, as well as concrete median barriers. Many states are considering soft metric for products also such as crash cushions. Your AASHTO M43 standard for aggregate already includes millimeter designations for aggregate. We are also using the AASHTO M160M standard for structural stapes, which is essentially a soft conversion. AASHTO M183M is being used for the steel properties such as 250 MPa to replace the PSI ratings used under the old system. Many other products are also being soft converted. Site lighting, corrugated metal pipe, and manhole covers among them. Other products such as breakthrough items on signs, as well as the signs themselves, are simply being used up until stock is exhausted, and then hard metric signs will be specified and procured. Some products are hard metric, physically changed to new metric sizes. The M164 metric bolts will now be used to replace the inch-size bolts used under the old system, and several sizes are reduced, reduces inventories. The AASHTO M170 metric standard for reinforced concrete pipe is also starting to be used, and due to tolerances remains compatible with the existing pipe. In terms of welded wire fabric, some firms are able to produce hard metric diameters and hard metric spacing for welded wire fabric, but minimum order quantities vary significantly. We have also begun to specify the AASHTO M31M metric rebar, which is essentially equivalent to the ASTM metric rebar, and also the M284 metric epoxy coated rebar. Expansion bolts are also now being widely specified in metric diameters. It is, of course, difficult to cover a complex topic such as metric construction in one brief session as in today. We do, however, hope we've given you an overall feel for the projects that are now being done around the country in the metric system, as well as a few of the more important lessons learned and technical questions that we commonly hear doing consultation for other organizations. Metric construction, we have found, is not difficult, but there is a learning curve effort required to get through it. The M3 video you viewed today is one of 3 sources of information that we have developed. The other documents are the M1 document, which lists metric projects being done around the country on a state-by-state basis. The M2 document is our metric design guide, which covers many of the topics we've covered today in more detail in handy written format. We'd be glad to provide those documents to you. Please feel free to contact us with any questions regarding metric construction, and we will try to be of assistance to you. We appreciate your time, and thank you for joining us today.